Good day to everybody. This is Harold Aljan P. Matamis speaking to present to you the improvised material as a requirement to our subject, Science Instructional Material Improvisation and Instrumentation with our professorial lecturer, Dr. Tessie Estrabo. I am pleased to present to all of you an improvised instructional material which is very useful especially when we are teaching grade 7 science in the K-12 curriculum, wherein acids and bases is one of the topics in dealing with chemistry concepts in the first quarter of the academic year. The instructional material that I have prepared is something that is common to most of us, the improvised pH indicator. This time, I will discuss brief ideas about a pH indicator, how to improvise one, and how to utilize this kind of IM in the teaching and learning process. But first, let us emphasize the learning objective which is included in the K-12 curriculum. The learner investigates the properties of acidic and basic mixtures using natural indicators. How do we investigate the properties of acidic and basic mixtures? How do we identify the acidity and basicity of a substance? What does it mean by a natural pH indicator? These are probably the questions that might come to a learner's thinking upon knowing the learning objective. That is why it is important for us to be knowledgeable of a natural pH indicator. In the past years, I have taught the said topic to my 7th grader learners. They have experienced the preparation and the utilization of the natural pH indicator from a sweet potato plant leaves, red cabbage, mayana plant leaves, or eggplant peel. They have tested the acidity and basicity of a substance using the natural pH indicator and further improved their learning using a supplementary activity worksheet. What is pH? We all know that pH is a measure of acidity and basicity of a material. The range goes from 0 to 14. 7 is the neutral, less than 7 indicates acidity, and greater than 7 indicates alkalinity or basicity. pH is a measure of the relative amount of free hydrogen and hydroxyl ions present in a substance. Say for example, water that has more free hydrogen ions is acidic, whereas water that has more hydroxyl ions is basic. What is a pH indicator? A pH indicator is a halochromic chemical compound added in small amounts to a solution. So the pH, acidity or basicity of a solution can be determined visually. Halochromic, meaning a material which changes its color when pH changes occur. The term chromic is defined as materials that can change color reversibly with the presence of a factor. In this case, the factor is pH. The pH indicators have this property called halochromism. Basically, the changes on colors or resulting colors depend on the acidity and basicity of a material. In the advancement of science and technology today, we already have the well-designed materials that can be used in detecting the pH level of a material. These are number 1, the litmus paper, number 2, the pH paper, and number 3, the pH meter. But let us always keep in mind that there are situations wherein these materials are not present. That is why, as a teacher, we need to improvise and devise such materials with almost same functionality and effectiveness. How to make the natural pH indicator. 1. Prepare the materials. Red cabbage, Brassica oleracea varcapitata F. rubra, eggplant peel, Solanum melongena, sweet potato leaves, Ipomea batatas, containers, cheesecloth, microwave, casserole or beaker suitable for heating and boiling. Microwave the cabbage or sweet potato leaves. When microwave oven is not available, boiling the leaves on a purified water can also be an option. Allow the leaves to cool for 10 minutes. Squeeze the leaves using a cheesecloth to release the extract. Filter the liquid from the cabbage through a filter paper or cheesecloth. Put a pinch of alum, or approximately 0.40 grams, into 100 ml of plant extract. This will make the extract more clarified. Add an approximately 30 ml of isopropyl alcohol to the extract. This is to prevent bacteria from living into it. Cool the extract, and lastly, use it as a natural pH indicator by putting at least 2 to 3 ml of it in each sample placed in a test tube. Prepare the samples. For this time, I have prepared 6 samples. 1 is vinegar, 2nd is bleach, 3rd is fresh milk, 4 is carbonated drink, 5 is salt water solution, and 6 detergent soap. I have put at least 2 to 3 ml of plant extract natural pH indicator in each sample, and it became very evident that there were changes in the color. Some became red, some became green, and some remained as violet. Again, this is because of that the natural pH indicator is containing the pigment called anthocyanin, which chemical structure gives the red cabbage or sweet potato leaves its color. It changes depending on the varying pH levels. For acidic mixtures or substances having the pH level of less than 7, colors might be from orange to red to strong red, while with mixtures and substances having the pH greater than 7, colors may change from blue to green to yellow. Those with neutral level or pH 7 will exhibit no change in color. In the recent years, I always made sure to incorporate activity worksheets for the learners so they could be guided in establishing their learning about acidity and basicity as well as natural pH indicators. These are the samples of my learners' works. They were able to test and investigate the nature and properties of acids and bases using the natural pH indicator, analyzing the table, showing the resulting colors, and identifying the approximate pH level using the pH chart helped them a lot in establishing their learning. As an additional feature and advantage of the natural pH indicator, it can actually be innovated into pH papers. Soak a filter paper or blotting paper in the extract. Let it dry after soaking. Cut the paper into strips and test the strips by dipping into sample substances. There might be changes on the color of the paper strips depending on the acidity and basicity of the material where it is dipped. I hope that you have learned a lot about acids and bases, and more importantly, natural pH indicators. Again, this is Harold Aljan Matamis, the presenter. Thank you and keep safe.